Alright, so we're going to look at some triangle stuff now. Specifically, we're getting into trigonometry, so a little bit of review of triangle ideas that you've done in the past. Do note you'll see little light pencil markings and things like that around. That's because I filmed most of this unit all in one straight shot, and the audio wasn't working. So now it is working, so I erased everything and restarted again. The things I do for you kids. Anyways, starting with the first bit here, we got just some angle ideas. So remember that if you have two lines intersecting, they'll create those four angles. The opposite angles are equal. So the red triangle or the red X's here and the blue circles, those are equal angles. Okay, they're opposite from each other. Okay. Also note that this is a straight line from here to here. Is a straight line. So the x plus the dot is equal to 180. And this happens in any situation. Here, you can add that dot and that x and you will still get 180. Why? Because the dot and the x combine to 180. In the next case, actually in the next few here, we have our parallel line ideas and theorems. So I have here two parallel lines in each case and a line cutting through. In the case of a line cutting through, you see here we have the Z or Z pattern. That Z or Z pattern is used in noting that the crook here of the Z's, those angles are equal. So if they're inside here, they're equal. And this kind of relates back to that opposite angle theorem. Now, it does not have to look like a Z. It might look like an N. It might look like a backwards Z. It might look like a backwards N. It doesn't matter. It could be on some skewed angle. As long as one orientation of that somehow gives you a Z, then you have the Z pattern. It's the same with the F. It's the same with the Z pattern. Doesn't matter which way they're facing. Okay, the F could be facing completely backwards here and face this way, as long and those two dots, or sorry, these two dots would be in the same spots. So it doesn't matter if it's mirrored, as long as you have that pattern emerging in that this angle within this crook is equal to this angle within this crook. And then in the last one, just to note that two of those interior angles here, they are both summing up to 180. Now, in some triangles, we had our equilateral triangles. Remember, equilateral triangles occur when you have three sides and three angles that are the same. You do not need to know both facts. If you know three sides are the same, these little tickies usually denote that, then you know the angles are the same, guaranteed. If you know the angles are the same, they happen to be 60 degrees each, then you know the sides are the same, guaranteed fact. Equilateral triangles guaranteed have both of these cases, so if one's present, they're both present. In the next case, we got isosceles triangle. These are triangles that have two sides and two angles equal. The third side, the third angle do not match up. So these two sides, these two angles will be equal. And again, if you know two sides of a triangle are equal, or you know two angles in a triangle are equal, then you know you have an isosceles triangle. You don't need to know both facts to know, or be given both facts to know that both are true. And in the last case, situation here, we got just a scalene type of triangle. But in this case, the important thing to note, in any triangle, this is true as well, be it 60, 60, 60, or this plus this plus this. Doesn't matter. Any triangle, all the angles, three angles sum up to 180 degrees. Now, that special triangle we've worked with in the past is the hypotenuse, and it's the right angle triangle, which has a hypotenuse, and the hypotenuse being that longest side in the triangle. It's pointed at like an arrow. The right angle, it makes like an arrow pointing at the hypotenuse. This never changes. No situation will you find the hypotenuse not being the longest side of a right triangle. The other two sides we usually label A and B. It doesn't matter which. Now, here I have the Pythagorean Theorem. Doesn't look like the one you were probably taught, because you were probably taught that a squared plus b squared equals c squared. However, people often forget that the hypotenuse has to be this value here, so I use h for hypotenuse. A and b doesn't matter which side's which, but the hypotenuse must be the part that you're equal. So the square of these two shorter sides added together is equal to the square of the larger side. So an example of that, here we have our hypotenuse. I'm going to call this side A because that 9 kind of looks like an A, and this side B. And then I take all that, I fill it in to my A squared plus B squared equals H squared formula. A squared, 9 squared plus B squared, X squared, and C squared is 15 squared. 9 squared, 81. The X squared stays the same. 15 squared is 225. And then we have the 81, we got to subtract it from the other side. So 225 minus 81. When I do that, I'm going to get 144. X squared is 144. We want X. So we got to take the square root. Take the square root of both sides, you're going to be left with X, and then the square root of 144, which is 12. And there's a Pythagorean theorem. Again, why do I use H instead of C like everybody else? Because H represents hypotenuse, and then you don't forget that the hypotenuse is that side that goes there all by itself, while the other two are added together. Now, flipping this over, we have a couple more things. Slope triangle. You might not have explicitly been told it was a slope triangle, or a rate triangle is another term that might have been used, but you might not have heard that. But when you look at that triangle to calculate slope on a linear graph, you have a rise and a run. The key idea here is that the rise in when we look at that triangle, how we like to draw it now, regardless of how you did it in the past, how we will draw them now is that the rise will always be the opposite side from the angle that we're dealing with. So if we're dealing with this angle, this will be the rise, this will be the run. So what that means is if I switch up this triangle, throw it around the other, where the angle is in the other corner. So I'm just going to make a smaller version of it. Okay, so if I have this smaller triangle here, but the angle's up here, this now becomes the rise, and this becomes the run. Okay, the rise is across from the angle. It's opposite from the angle, the furthest side from the angle. Okay, and it's still a rise because I can turn the triangle that way, and it's still now rising up. The last part here is equivalent ratios. So equivalent ratios, we're just solving for the x here. The way I recommend doing this is to divide this pair first and then move this 9 over. I know you can cross multiply and do it. If that makes you comfortable, feel free to cross multiply. I will not be using cross multiplying in the sense of multiplying both bottoms by both tops. I will be doing it this way throughout this unit because we're going to be doing some questions that relate to this. So I have x divided by 9, and that equals this division, which is 1, 1, 1, 1. And then I take that 9 and I got to multiply it on the other side. And so x equals 0.9999. Sir, why don't you just round that to 0.1? Why don't you just round that to 1? I want you to become familiar with the idea of having 4 decimal places. 4 decimal places becomes very important in this unit for accuracy. Those of you that like to round things off to whole numbers, we need decimal places in this unit. We're going to be using them a lot. 4 decimal places is our ideal number. Okay, another example. In this case, the x value is on the bottom, which throws a slight twist to the problem. The start is the same. 9 over x, 10 divided by 90 is 0.1111. 4 decimal places. Now what I got to do, take that x, I got to multiply it on the other side. So I get 9 equals 0.1111x, and then divide 9 by 0.1111. And that there will give me the value that I'm looking for. And in this case, 9 divided by 0.1111 is going to give me 81 equal to x. All right, so that is just some quick review of some of the concepts that you will be using and applying in this unit.